This is Santhosh. I'm working as assistant professor in Mlritm institutions. Today I'm going to explain about signal analyzers. Before going to this topic, first of all, what is signal analyzer? We can define signal analyzer as electronic test instrument to measure the quantity of the signal like frequency, amplitude, distortion, modulation, noise of the signal. These instruments we can use in electronic circuits and communication systems. What this analysis will do? These analyzers will measure the frequency, amplitude, and distortion, noise of the signals. In electronic instruments, we can produce different types of signals along with the actual signal, like noise, distortion, all those signals. Along with the actual signals, all these distortion version of the signals will produce. To measure these quantities, we can use signal analyzers. What are the coming to different types of signal analyzers? What are the different types of signal analyzers? We can categorize the signal analyzers based on the applications of the signal analyzers and usage of the signal analyzers. Mainly, these signal analyzers classified as AF wave analyzers, HF wave analyzers, harmonic distortion analyzers, spectrum analyzers, power analyzer, heterodyne analyzers. These types are based on the application of the analyzers and based on the usage of the analyzers at different applications. First one is AF wave analyzer. What is AF wave analyzer? The name itself shows that AF wave analyzers analyzes the signals in the frequency range of 20 Hz to 20 kHz. The working principle of these AF wave analyzers is mainly based on the tunable bandpass filter. These tunable bandpass filters select the frequency at a time, one frequency, and rejects all other frequency components. The selected signal is passed through the detector and meter. What are the applications of these AF wave analyzers? The AF analyzers are mainly used in testing audio amplifiers, measurement of harmonic distortion in audio frequency applications, audio equipment analysis, and telephone communication circuits. These are the mainly used applications of AF wave analyzers. Coming to next type of analyzers, HF wave analyzer. The name itself shows that HF means high frequency, like 20 kHz to up to several megahertz. Applications we can use this type of analyzers. The HF wave analyzer mainly consists of RF circuits to select over some range of frequencies. In this circuit design, the signal is detected and the amplitude is we can measure. HF wave analyzer mainly used in different applications like radio transmitter testing, RF communication systems, high frequency circuit analysis. These are the main applications of HF wave analyzers. Mainly these analyzers we can use in HF range applications, mainly in telecommunication applications. The next type of analyzer is harmonic distortion analyzer. The harmonic distortion analyzer measures the distortion produced in amplifier and electronic circuits. The circuit design of this harmonic distortion analyzer mainly consists of notch filter that removes the fundamental frequency from the different frequency components. The notch filter mainly removes the other frequency components and it will pass only one frequency, fundamental frequency components. The general formula for distortion analyzer harmonic distortion is V2 square plus V3 square plus V4 square, like this, divided by V1. Here V1 is the fundamental component and V2, V3 are the voltages components of harmonic components. This is the formula for the total harmonic distortion in the signal. So, what are the coming to the applications where we will use this harmonic distortion analyzers? Mainly, these harmonic distortions analyzers used in testing audio amplifiers, measurement of signal quality, and communication equipment testing. These are the main focus areas of applications of harmonic distortion analyzers. Coming to next type of analyzers, heterodyne wave analyzer. What general meaning of heterodyne means combining. Means we can combine the two different signals and produces some and different signals. This heterodyne wave analyzer mainly consists of mixer, local oscillator, and input signal. These two input signals are added in mixer and produces some and different signals with IF range. So the two signals are mixed in mixer and output of the signal will produce some and different signals. This IF components is given to the IF amplifier and finally given to the detector and meter circuit. So for this design of heterodyne wave analyzer, mainly we can use IF filter. What are the advantages of this heterodyne wave analyzers? Heterodyne wave analyzers have high frequency resolution. Due to the high frequency resolutions, it will measure small quantity of signals. Mainly these are used in radar applications and satellite applications. In that applications, very small quantity of signals will be measured. Accuracy is more important in those applications. In this type of applications, mainly we can use heterodyne wave analyzers. What are the main applications of other heterodyne wave analyzers are precision frequency analysis. Means in mixed signal frequency, we have to take the some particular frequency component. Precision frequency analysis, some particular component frequency we have to analyze. At that applications, we have to use this heterodyne wave analyzers. The other application of this heterodyne wave analyzer is communication signal testing. In RF and AF signal communications, we have to check the signals before giving the actual signal to the system. We have to check the signal. What are the other important application of heterodyne wave analysis? RF laboratory measurements. Mainly these heterodyne wave analyzers are used in RF laboratory equipment testing and signal analysis. Why? Because this heterodyne wave analyzers have high frequency resolution with very small signal quantity measurement. The other type of analyzer is the spectrum analyzer. Spectrum analyzer. The spectrum means generally we can define spectrum as the graphical representation of the any signal. So this spectrum analyzer displays the signal in the form of waveforms with frequency and amplitude. The frequency component corresponding to that frequency component, it will display the amplitude of that signal. So these spectrum analyzers mainly measured in horizontal with frequency and vertical with signal amplitude or power. So what is the general working principle of this spectrum analyzers? The main working principle of this spectrum analyzer is the input signal is swept through frequencies. So this is the main working principle of spectrum analyzer. Swept means the signal will be changed over some particular frequency. Each frequency component is displayed on the screen. Corresponding to that frequency component, the amplitude of that frequency component will be displayed on the screen. What are the applications of these spectrum analyzers? Where we will use this spectrum analyzers? Generally, we can use this spectrum analyzers at RF frequency range. At that frequency range, we had to analyze the RF signal amplitude and frequency component measurement we can use. The other important application of the spectrum analyzer is the wireless communication testing. In wireless communication, we will use different types of communication equipments, amplifiers, and different components. For testing of those wireless communications, we can use this spectrum analysis to check the performance of different wireless equipments. These spectrum analysis mainly used in satellite communications for spectrum analysis of the radar signals. The other important application of the spectrum analysis EMI EMC measurement. In EMI EMC measurement is the signal parameters measurements. These are the signal parameters measurements mainly used in satellite applications. The other important application of the spectrum analysis is satellite and radar antenna systems. The spectrum analysis we can keep in satellite and radar antennas to analyze the remote planet signals, radar frequency signals, and based on the spectrum of the signals, we can judge the distance between different planets. So all these are the spectrum analyzers. The other most important signal analyzers is the power analyzer. Power analyzers, the name itself shows that it will measure the power of the electrical quantity or electrical signals in the form of frequency and power calculations. For power analysis, mainly we can calculate voltage, current, real power, apparent power, power factor, harmonic. These are the different power parameters we can measure by the power analyzers. Coming to the applications of power analysis, we can use in mainly these power analysis we can use to test the motors and generators. We can use for checking the performance and running condition of the motor and generators. The other application of this power analyzer is energy efficiency analysis. In these applications, we can measure how much the energy is efficiently utilized by the motors and generators. By this, we can check the performance of the motors and generators. These power analyzers used in power electronic testing. Power electronic testing means in power electronic components, we have to measure the accuracy and performance of the power equipment components. The other important application of this power analysis is electrical power system monitoring. It shows that it will monitor the power utilization of the electrical power stations. Mainly, we can use these power analyzers in electrical applications, power plant applications to measure how much the power is generated, how much the power is utilized, and how much the power is consumed, and how much power is wasted. We can use in electrical power plant stations for measurement of power in analyzers. Okay, these are the different types of analyzers, signal analyzers we can use in electronic measurements and instrumentation. Nowadays, different smart power analyzers are used in the electronic measurements and instrumentation systems with a digital display. Due to the advancements in technology, we are using AI-based power different signal analyzers to analyze the signals delivered at the input and output of any system. Thank you so much.